discuss about binomial distribution. So binomial distribution is based on a Bernoulli trial, and this one is derived by the Bernoulli, James Bernoulli. So first we discuss about a Bernoulli trial, and Bernoulli trial based on a Bernoulli experiment. So first we discuss about a Bernoulli trial, then we discuss about a binomial distribution. So here binomial distribution, if we write a binomial distribution, binomial distribution, binomial distribution. So this one is under the category of a discrete probability distribution. Under the category of a discrete probability distribution. Probability distribution. Discrete probability distribution. So this one, as earlier we said, that this one is depends on Bernoulli trials. So what is the Bernoulli trial? And Bernoulli trial can be understood with the help of a Bernoulli experiment. What is a Bernoulli experiment? If we perform any random experiment repeatedly, but there is a two possibility, either we success or we failure. Means there are only two chances. So in any experiment, means then such experiment is called what? Then such experiment is called a random experiment. Oh sorry, Bernoulli experiment. So here Bernoulli trial. Here we write what? Bernoulli trial. Bernoulli experiment. Experiment. So if in any experiment there are only two possibilities, either success or failure, then what will happen? Suppose here we perform any experiment n time we perform any experiment, and Bernoulli n trial of Bernoulli experiment. Bernoulli experiment. N trial of a Bernoulli experiments. So among n trial, what is the probability of x success? Or means a 1 success, 2 success, 3 success. Similarly, there is x success. So this one is defined by the what? Binomial probability distribution. So here there is an n trial of a Bernoulli experiment. So suppose here we perform the n trial, then what are the possibility? Either we got the success or we failure. Success, failure, success, like this one, and here success. These are the n trials. N trial of a Bernoulli experiment. So what is the probability of x success? Means 1 time success, 2 times success, 3 times success, or x success. So how many number of s? There is a xs. If we equate the s at one place, means write the s, and how many number of s? There is a xs. So how many number of failure? Means f. How many number of f? Since there is a total n trial, this one is a total n trial, then this one is what? This one is n minus x. This one is a total n trial. This one is a total n trial. This one is a total n trial. This one is x axis, then how many number of failure? Total number of failure is what? N minus x. So suppose the probability of a success is a what? P. And probability of a failure is a Q. Because there is only two possibility. Then Q can be written as what? 1 minus P. Q can be written as 1 minus P, because there are two possibilities, either we got either be success or be failure. Failure. So what is the value of P plus Q? P plus Q equal 1. So now it will be find the probability of a X success out of a N trial. Probability of a X success out of a N trial. So probability of a X success means that S how many times? X time. How many number of failure? Failure become F up to F. How many number of failure? N minus X failure. So since the trial are independent to each other, then by the property of probability means compound probability of a compound law of probability, this one equal what? This one equal means probability for the multiplication of different events or different outcomes. So probability of a success, this one is the probability of a success into probability of a success into probability of a success. How many times? X times. Probability of a S. How many times? X times. So this one is by the multiplicative law for probability as well as compound law for probability. Probability of a success, probability of a success, probability of a success into probability of a failure, probability of a failure, up to what? Probability of a failure. How many times? This one is N minus X times. N minus X times. And what is the probability of a success? Probability of a success is a what? P. Here we write the P and P up to how many times? X times. And probability of a failure Q, how many times? N minus X times. So this becomes P to power X and Q to power N minus X. Q to power N minus X. This was the probability of this one. Probability of a success up to S, X time, and probability of a failure means if we write F, probability of a failure. So this becomes probability of a failure up to N minus X time equal probability P to power X and Q to power N minus X, where P is the probability of a success and Q is the probability of a failure. Probability of a success and probability of a failure. But this probability of a success out of N times may be occur how many number of ways? This may be occur by the how many number of ways? NCX, because there is a total N trial and out of N trial we choose X trial. So what are the total possibilities? Then by the probability of probability law of addition means one possibility plus second possibility plus third possibility, third way, fourth way, fifth way up to how many number of ways. So if we add all the ways, because there is NCX ways, so what is the probability of this one? So probability become what? Probability become NCX. NCX, because this can be written as, for example, suppose there is a 3S and 2 failure. How many number of trials? There is a 5 trials. So you may write this one S, F, S, like this one. In a 5 trial, the success may occur continuously 3 times, but in a second case, 1 time success, then 2 times failure, then 2 times success. Maybe 2 times success, then 2 times failure, then 1 time success. So this one is a success, failure, and success. So these are the different ways. So what is the total number of ways? So if there is a 3 success and 5 trials, so 5C3. So here there is a N trial and X success. So total number of ways is what? NCX, P to power X, Q to power N minus X. So this one is a what? This one is treated as a what? This one is treated as a probability mass function of a binomial distribution. This one you can consider as what? Probability mass function. Probability mass function of a what? Probability mass function of a binomial distribution. Binomial distribution. Binomial distribution. Binomial distribution. Binomial distribution. So you may also write this one in this way: probability of a x equal what? NCx p to power x q to power n minus x. If x equal what? 0, 1, 2 up to what? N number of a trial, because you cannot exceed the value of x after n, because total number of a trial is what? Total number of a trial is a n. So if we formally define the binomial probability distribution, means mathematical definition of a binomial probability distribution. Binomial distribution for a random variable x. Binomial probability distribution. Probability distribution for the discrete random variable, for the discrete random variable x, random variable x for finite number of a trial, for finite number of a trial, finite number of a trial, finite number of trial, finite number of a trial, binomial probability distribution for random variable x for finite number of a trial is defined as probability of x equal NCx p to power x q to power n minus x if the value of x ranges from 0, 1, 2 up to n. Otherwise, what is the probability? Probability equals 0. Otherwise, probability is a 0. Otherwise, probability is a 0. So this one is the probability of x equal x, NCx p to power x q to power n minus x. Otherwise, value is a 0. You may also say this one is what? This one is the probability mass function for this discrete probability distribution. So now question is this one depends on a Bernoulli trial, and this one is a probability mass function. Then why this one is called binomial distribution? So why this one is called binomial distribution? Because if we closely observe the probability mass function, means probability distribution of a binomial distribution. So for x equal to 0, what is the probability? For x equal to 0, probability x equal to 0, what is the probability? Probability is NC0 p to power 0 q to power n minus 0. And probability for x equal 1 is about NC1 p to power 1 q to power n minus 1. Similarly, probability for x equal n equal what? NCn p to power n q to power 0. This one is the probability. So you may obtain these values, these terms, by the binomial expansion of a what? P plus q to power n. Binomial expansion of what? Binomial expansion of a p plus q to power n. What is the binomial expansion of a p plus q to power n? It will be right here. This one is what? NC0 p to power x p to power 0 q to power n minus 0 plus NC1 p to power 1 q to power n minus 1 plus NC2 p square q to power n minus 2. And similarly, last one is NCn p to power n q to power 0. So if you closely observe, the first term means probability at x equal to 0 gives the first term of a binomial expansion of a p plus q to power n. This one is the first term, and this one gives the probability at x equal 0, and this term gives the probability at x equal 1, this term gives the probability at x equal 2, and this term gives the probability of x equal n. Due to this reason, this one is called what? Binomial distribution, because we able to find out the probability at x equal 0, x equal 1 up to x equal n using the binomial expansion of p plus q to power n. Due to this reason, this one is called what? Binomial probability distribution, binomial distribution. Here, this one, probability at x equals 0, probability at x equal 1, x equal 1, and probability at x equal 2, and similarly probability at x equal n. So this one is a what? This one is a why this Bernoulli experiment, and after the Bernoulli experiment we define the probability mass function, why this one is called binomial distribution. So if we try to solve some numerical example based on a binomial distribution. So very simple example, if we take a simple example, suppose example 1, if we toss a coin 10 times, toss a coin 10 times repeatedly, then find the probability of getting 7 success. Find the probability of 7 success. Exactly 7 success. If we write here exactly 7 success. Exactly 7 success. Then find the probability. We write a 1 in terms of a 1 and 2. Find the probability first. Exactly 7 success. Second, at least 7 success. And success is what? And toss a coin 10 times repeatedly, then find the probability. If head will occur, then either you write this one is a head represent the success. Occurrence of a head represent the success. Occurrence of head is about success. Occurrence of a head is about success. So how we find the probability of exactly 7 success? Means exactly 7 head. Exactly 7. Out of a 10 times, if we toss a coin 10 times, then what is the probability of exactly 7 success? So what is the solution here? So what is the probability of occurrence of a head? This one is a probability of a success equal P. Occurrence of a head is what is the probability? Probability is a 1 by 2, because if we toss any coin, probability of a success, probability of coming a head, occurrence of a head is a what? 1 by 2. And probability of occurrence of a tail is also a 1 by 2. P equal 1 by 2, and probability of a failure means if there is a tail, then this one is a what? This one is also a 1 by 2. So probability of a success is a 1 by 2, and probability of a failure is a 1 by 2. Now, what is the total number of a trial? Total number of a trial is n. N equal what? N equal 10. N equal 10. So if we solve the first problem, exactly 7 head or exactly 7 success. So what is the value for x? X equal what? 7. So since there are only two possibilities, either we success or failure, so this experiment is a what? This experiment is a random experiment, and we repeat this experiment 10 times. So this one is a what? Random trial. So x equals 7. Then according to the binomial distribution, probability at x equals 7 equal what? 10c 7 p to power what? P here. P is the what? P to power x, if we write the p to power 7 and q to power 10 minus 7 q. So here this becomes factorial 10 divided by factorial 7 into factorial 3 into 1 by 2 to power 7 into 1 by 2 to power 3. So this one equal what? 10c3, this one is a 10 into 9 into 8 and divided by 3 into what? This becomes 10 into 9 into 8 divided by 3 into 2 into 1 into 1 by 2 to the power 10, and to the power 10 is a what? 1024. So what is the value? This becomes here 1 by 2 to the power 10. So this one cancel out. It is a 9, 2, 5 is a 10, 5 is a 10, if we write here 5 is a 10. So 5 is a 15, 15 8 is a, what is the value? Value is a 120. So this one is a 120 divided by 2 to the power 10 is a what? 1024. So this one is a what? This one is the probability of exactly 7 heads, 7 success. And if we talk about the second question, probability of exactly 7 success, at least 7 success. So what is the meaning of this one? We try to find out the probability of x is a greater or equal to 7 plus greater or equal to 7, and this one equal to what? At least 7 success. At least there is occurrence of at least 7 head. Maybe this one is 8 head, 9 head and 10 head. So what is the value for this one? Value for this one is what? Probability of x equal to 7 plus probability of x equal to 8 plus probability of x equal to 9 plus probability of x equal 10. This one is the probability of x equal 10. So if we write the calculation of this one here, probability of x greater or equal to 7, this one equal to what? Probability at x equal to 7, this become what? 10c 7 1 by 2 to the power what? 1 by 2 to the power, here x is a 7 into 1 by 2 to the power 3 plus 10c 8 1 by 2 to the power 8 into 1 by 2 to the power 2 plus 10c 9 1 by 2 to the power 9 into 1 by 2 to the power 1 plus 10c 10 1 by 2 to the power 10. So this one is a result. So if we simplify this one, then this one is a 1 by 2 to the power 10. Here 1 by 2 to the power 10, 1 by 2 to the power 10, 1 by 2 to the power 10, 1 by 2 to the power 10. This one is outside. Inside 10c7 plus 10c8 plus 10c9 plus 10c10. So what is the value for this one? This one is a 1 upon 2 to the power 10. This one is again a 1 upon 1024, because 2 to the power 10 is a what? 1024. Now what is the value for 10c7? 10c7 is a what? 120. 120 plus 10c8. 10c8 become what? 10 into 9 divided by 2. So this one is a 40. 40, and this one is a what? This one is a 10c9. This one is a 10 factorial 10 upon factorial 9 into factorial 1. This one 10c10 is a 1. So what is the value for this one? 120 plus 40, 160, 170, 171 by 1024. 171 by 1024. Once we verify the result, is 6 by 1024. So what is the value for 10C8? Here you will be write 10C8. 10C8, this one is a what? Factorial 10 divided by factorial 8. Factorial 8 into factorial 2. So this one is a what? This one is a 10 into 9 divided by 2. This one is a 5. This one is a 45. Sorry, this one is a 45. So if this one is a 45, then 120, 45 plus 55, 55, 56. So this one become what? 176. So this one is the answer. This one is the probability of at least 7 heads, and this one is the probability of exactly 7 heads. So this one is what? 120 by 1024. So there is a need to, once you check the calculation with the help of a calculator, if there is something wrong. So you may check with the help of a calculator the calculation of these terms. So this one is what? This one is a very simple example of how we solve questions of probability with the help of a binomial distribution. Now we discuss some properties of a binomial distribution. Now we discuss some properties of a binomial distribution. First we discuss about moments. What are the moments of a binomial distribution? So first we try to find out the moments about a origin. Then we try to express the moments about origin in terms of moments about mean. Means we find the mu1 dash, mu2 dash, mu3 dash, mu4 dash. Then we write mu1, mu2, mu3 and mu4, because mu1, mu2, mu3, mu4 is what? Moments about the mean. Mu1 dash, mu2 dash, mu3 dash, mu4 dash is a moment about any point. So moments of a binomial distribution. Moments of binomial distribution. Binomial distribution. So binomial probability distribution. So here if we talk about what is the mu1 dash? Moments about origin. Moments about origin. So this can be defined as what? This can be defined as what? As earlier we discussed about this one equal to the what? Expected value of x. So mu1 dash equal expected value of x, random variable x. And since binomial distribution is about discrete probability distribution, so here what is the expected value of x? Summation minus infinite to infinite x, probability of x equal x. So as we know that probability of x equal x in case of a binomial distribution is only for the 0 to n. So this can be written as from minus infinite to minus 1 x into probability of x equal x plus summation n equals 0 to x equals 0 to n x, probability of x equal x and plus last one is a what? Last one is a summation x equal n plus 1 to infinite x into probability of x equal x. So here we know that in case of a binomial distribution, probability is only defined for 0 to n. For all other, what is the probability? Probability become 0. So what is the value for this one? Now mu1 dash become what? If we write here, mu1 dash become this become first term become 0 and third term also become 0. Mu1 dash becomes summation x equal 0 to n x, probability of x equal x. So now just we put the value for probability of x equal x by the binomial distribution. What is the probability of x equal x? So this becomes summation x equals 0 to n x into ncx probability p to power x and q to power n minus x. So if we simplify this one, then this becomes summation x into factorial n divided by factorial x into factorial n minus x into p to power x and q to power n minus x. So if we simplify this one, factorial x can be written as x into factorial x minus 1. So if we simplify this one, then this becomes summation x here n into factorial n minus 1. We may write this one factorial n as a factorial n minus 1 divided by what? Factorial x can be written as x into factorial x minus 1, and this one is a factorial n minus x minus 1 plus 1, like this one. So here this one, and here we write p into p to power what? X minus 1. P into p to power x minus 1 is what? P to power x, and here again q to power n minus x, q to power n minus x. So here n and p is free from the summation, because summation is vary from x equals 0 to n. So n and p is free from here, x and x cancel out. So this becomes np, and this becomes summation factorial n minus 1 divided by factorial x minus 1 into factorial n minus x into p to power x minus 1 into q to power n minus x. So if we closely observe, this one is a what? P plus q to power what? P plus q to power n minus 1. So this may become a what? Np into p plus q to power n minus 1. And p is the probability of a success and q is the probability of a failure. So what is the value of p plus q? P plus q become 1. So this become what? Np into 1 into power n minus 1, and is a positive number. So what is the value? Value become n. So this one is a what? This one is a mu 1 dash. Similarly we find what? Similarly we find mu 2 dash, mu 3 dash and mu 4 dash. So here there is one thing there is a need to clear, means this one is a what? P plus q to power n minus 1. So ncx p to power x q to power n minus x, this one is a p plus q to power n. But here if this become n minus 1, this become n minus 1 cx minus 1. N minus 1 cx minus 1 p to power x minus 1 q to power n minus x. So this one is in this form, but here the value of n become, here the value of n become n minus 1. So here p plus q to power n, so here p plus q to power n minus 1. So this one is the reason why we write here this one is a p plus q to power n minus 1, because this all the term is this one is a binomial expansion of a p plus q to power n. So here this one is a what? This one is a mu 1 dash. So similarly we find a mu 2 dash. What is the value of mu 2 dash? So mu 2 dash is a what? Expected value of x square. Expected value of x square. This one is a what? This one is a summation x square, probability of x equal x. So this become what? This become, and x square can be written as what? Summation x minus 1 plus x, because x square minus x plus x, this one, into probability of x equal x. Now if you simplify this one, then this becomes summation x into x minus 1, probability of x equal x, this become what? ncx p to power x q to power n minus x plus summation x into ncx p to power x and q to power n minus x. So these are the, this one is a term. So if we simplify, if we closely observe, this one is a what? This one is a case of a mu 1 dash. So what is the value for this one? The value for this one is np. And if we simplify this one in a similar manner, so what is the value for mu 2 dash? Mu 2 dash become, if we simplify this one, x minus 1, if we write here, one step more, x minus 1 into n minus 1 into factorial n minus 2 divided by x into x minus 1 into factorial x minus 2 into factorial n minus x into p to power x minus 2 into what? P square. Then this become what? P to power x into q to power n minus x plus, and after simplification of this one is a case of a mu 1 dash. The value for this one is a np. There is no need to again simplify this one. So if we simplify this one become n minus 1 p square outside, and this become p plus q to power n minus 2. So mu 2 dash become n minus 1 p square n minus 1 p square, and this becomes p plus q to power what? N minus 2 plus np. So this becomes mu 2 dash equal n minus 1 p square plus np. This is the value of mu 2 dash. Similarly, we find out what? Mu 3 dash, mu 4 dash. So next I am not going to derive the mu 3 dash, mu 4 dash. Directly we write the value of mu 3 dash and mu 4 dash. Then we find the value for mu 2, mu 3, mu 4. So mu 2 dash is this one. In a similar manner, we find mu 3 dash is expected value of x cube, summation of x cube, p to power p probability of x equal x, and simplify in this manner. Then we find the value of probability of x equal what? Probability at x equal the value of mu 3 dash. The value for, now we summarize this one. So what is the value for mu 1 dash? We find the value for mu 1 dash equal np, and mu 2 dash equal, as we derived earlier, n minus 1 p square plus np, and mu 3 dash equal what? n minus 1 n minus 2 n minus 1 n minus 2 n minus 2 n minus 2 p cube plus n minus 1 n minus 1 p square plus np. This one is 3 times of n of mu 4 dash. This one is n minus 1 n minus 2 n minus 3 p to power 4 plus, what is the value? Value is plus 6 n minus 1 n minus 1 n minus 2 n minus 2 p cube plus 7 times of n minus 1 n minus 1 p square plus np. So these are the value for mu 1 dash, mu 2 dash, mu 3 dash, and mu 4 dash. So once we have a value for mu 1 dash, mu 2 dash, mu 3 dash, and mu 4 dash, then we are able to find out the value of mu 2, mu 3, mu 4. So by using the relation of what? By using the relation of mu 2 and mu dash. So what is the value for mu 2? So obviously we know that what is the value for mu 1? Mu 1 equals 0. What is the value for mu 2? Mu 2 equal mu 2 minus mu 2 dash minus mu 1 dash whole square. So what is the value for this one? If we put the value for mu 2 dash is n minus 1 p square plus np minus mu 1 dash whole square. This will be n square p square. So if we simplify this one, so this become what? N square p square minus np square, and this one cancel out. After simplification, this become np minus np square. So this become np with the outside, this become 1 minus p, and what is the value? Value become np2. So what is the value of mu 2? Mu 2 become NPQ. In a similar manner, we use the relation between mu 3 and mu 3 dash, mu 2 dash and mu 1 dash, then we find the value for what? Mu 3. And what is the value for this one? After putting the value for mu 3 dash, mu 2 dash and mu 1 dash, we find the value for mu 3. So what is the value for mu 3? Directly here we write the value for mu 3, NPQ into Q minus P. This one is the value for mu 3. Similarly, we write what? We write mu 4. Mu 4 equal what? Mu 4 equal NPQ into what? NPQ, here we noted down the value for this one. 1 plus 3n minus 2. 1 plus 3n minus 2 PQ. 1 plus 3n minus 2 PQ. N minus 2 PQ. So this one is a value for this one is a value for mu 4. So mu 1 equal to 0, mu 2 equal NPQ, and mu 3 equal what? NPQ Q minus P, and mu 4 equal NPQ 1 plus 3 n minus 2 PQ. So now what is the so here if we closely observe the value for mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash, if we have two terms n and p, then we are able to find out what? Mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash, as well as mu 2, mu 3 and mu 4. So if we have only two terms n and p, so then we find the all values of a moment mu 1, mu 2, mu 3, mu 4. Similarly, mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash, mu 1, mu 2, mu 3 and mu 4. If we have n and p, then also we will be able to find out the value of a q, because q equal what? 1 minus p. So also binomial distribution can be defined v. This one is a notational form of a binomial distribution. This one is a two parameter function v and p. If we have a value for n and p, then we are able to find out the all statistics of a binomial distribution. So, and similar manner, we also able to find out what? We also able to find out what? We also find out the value for beta 1. What is the value for beta 1? Beta 1 equal mu 3 square upon mu 2 cube, and beta 2 equal what? Mu 4 upon mu 2 square. So just we put the value for here from here, then we find what? Mu 3 square. Mu 3 square is a what? This one is a n square, p square, q square, and q minus p whole square divided by what? Divided by mu 3 square upon mu 2 cube. What is the mu 2 cube? n cube, p cube, q cube. So this one cancel out by this one. So what is the value? Value become q minus p whole square divided by what? npq. This one is the value for what? Beta 1. And similarly, we simplify the mu 4 upon mu 2 square. What is the value for beta 2? Beta 2 means we write the value for beta 2. This one is a npq. This one is a 1 plus 3 n minus 2 pq divided by what? Divided by mu 2 square. Mu 2 means npq. N square, p square, q square. Then this one cancel out by this one. After the simplification of this one, I have already noted down the value for this one. The value for this one is a 3 plus 1 minus 6 pq. This one is a 3 plus 1 minus 6 pq upon npq. This one is a value for beta 2. This one is a value for beta 2. Once we again verified 3 plus 1 minus 6 pq upon npq. So this one is a what? This one is a value for beta 1 and beta 2. So with the help of these values, what we able to draw? We able to find out the value for npq. So here why we concentrate on np and npq. So mu 1 dash give the what? Give the value of mean. This one will give the value of mean. And also we know that mu 3 give, this one is mu 2. This one give the what? This one give the mu 2 equal what? Variance. variance. And this one is what? This one measure the coefficient of skewness. Either the curve is a symmetric curve or not. And this one measure the flatness. Either the curve is a flat or not. So if beta 2 equal to 3, then what is the value? Means this portion is equal to 0. Then the binomial distribution is a normal curve. If beta 2 is greater than 3, then leptokurtic, and if beta 2 is less than 3, then this one is a platykurtic. So these are some statistics of a binomial distribution, and mean is about NP and variance is about NPQ. So if we try to observe the NP and NPQ, means a mean and variance. Mean is what? If we write here, mean equal NP, and variance is what? Variance is a NPQ. And the value of a Q, the value of a Q is a greater than 0 and less than 1. Then what is the relation between mean and variance? Q is lie between 0 to 1. Then NPQ multiplied by a number which lie between 0 to 1 means a fractional value. Then variance is a what? Variance is always less than mean. Means so in a case of a binomial distribution, always variance is less than mean. This one is a very important result, means a very beautiful result. I mean, what is the relation between mean and variance in case of a binomial distribution? Always variance is less than mean. So this one is a what? This one is a relation between mean and variance in case of a binomial distribution. Example based on a mean and variance. If mean equal 4 and variance equal 3, then find binomial distribution. Binomial distribution. What is the solution? Solution is a what? Solution is in case of a binomial distribution, only there is a need to find out the two parameters, because we know that on the basis of a two parameter n and p, we are able to find out all statistics of a distribution. So there is a need to find out the n and p, because v and p, this one is defined as p and p. Sometimes here also we write a q, but q can be derived with the help of a p. Q equal what? 1 minus p. So there is a need to find out what? The value of a n and value of a p. Value of a n and value of a p. So we know that mean equal what? In case of a binomial distribution, mean equal np, and variance equal what? Variance equal npq. And we know that npq, variance upon mean, npq upon np, because mean is what? 4 and variance is what? 3. So this one equal 3 by 4, and we simplify this one, np cancel out, q equal what? 3 by 4, then p equal what? 1 minus q, and this one 1 minus 3 by 4, this one equal 1 by 4. If p equal 1 by 4, then what is the value of n? N into p equal 4, and p is a 1 by 4, so n into 1 by 4 equal 4, then n equal what? N equal 60. N equal 60. So this one is a what? This one is a, we are able to find out the value of n, and we are also able to find out the value of p. So what is the binomial distribution? Binomial distribution becomes b. N is a what? N is a 16, and p is a what? P is a 1 by 4. So if we write a binomial distribution, here, if we write a binomial distribution here, so Vn binomial distribution for this case, this one is the probability of x equal what? N is what? 16 cx, p is what? 1 by 4. 1 by 4 to power x, and q is what? 3 by 4 to power 16 minus x. 16 minus x. This one is a what? Probability mass function. If x varies from what? X varies from 0, 1, 2 up to 60. So this one is a what? This one is a binomial distribution of a, if mean is a 4 and variance is a 3. Now we discuss about last topic of this lecture is how we find the moment generating function of a binomial distribution. So as earlier we find directly how we find the mu1 dash, mu2 dash, mu3 dash, mu4 dash. If we have a moment generating function, then we easily be able to find out the value of mu1 dash, mu2 dash, mu3 dash and mu4 dash, because the coefficient of a t to power r upon factorial r represent the mu r dash. So moment generating function, moment generating function of binomial distribution. Binomial distribution. So moment generating function. So as we know that what is the moment generating function, mxt equal what? Expected value of a e to power tx. Expected value of a e to power tx. So here, in case of our, because binomial distribution is a what? Discrete probability distribution. So what is the expected value of a e to power tx? This becomes summation e to power tx into probability at x equal x. So here, since this one is defined, probability is defined from 0 to n. For all other values, what is the value? Value becomes 0. So this one is a what? This one equal summation e to power tx ncx p to power x and q to power n minus x. So here if we simplify this one, x equal what? 0 to n, because for all other the probability become 0. So this become ncx. Here we write what we write here. So if we write again, this one is the what? ncx e to power tx ncx e to power x and q to power n minus x. So ncx here, ncx, typically we write the what? P. So this become summation ncx into e to power t into p to power x into q to power n minus x. Since this one is a what? P plus q to power n. So this one is a what? This one become what? Q plus means in place of a p, what become? E to power, what is the value? E to power t into p. E to power t into p plus q to power what? N. This one is a what? This one is a moment generating function. mxt equal n. So if we write here, what is the meaning of this one? Meaning of this one is a what? Meaning of this one is what is the moment generating function? Moment generating function becomes this one. P into e to power t plus q to power n. So this one is a moment generating function. mxt equal q plus t into e to power t to power n. So now we expand this one, then this become what? First term become nc0 t into e to power t to power what? This one into nc0 to power, here if we write a 0 into q to power n. And similarly, if we write nc1 p into e to power t 1 into q to power n minus 1 and so on. And last term is what? Ncn p into e to power t to power n into q to power c. So if we simplify this one and equate the coefficient of our t and coefficient of a t upon factorial 1, t upon factorial 2, then we find the value of mu 1 dash, mu 2 dash, mu 3 dash and mu 4 dash and so on. So similarly we find the mean deviation of a binomial distribution, means all other statistics we able to find out with the help of a probability mass function of a binomial distribution. So this one is a very important probability distribution in a category of a discrete probability distribution. So in the next lecture we discuss about another discrete probability distribution known as a Poisson distribution. So thank you watching my videos. Thank you.